Example, let theta be an acute angle of a right triangle for which sine of theta equals 3/5. Find the tangent of theta. So what's different here? Look at the sine function you're given. Are you given the input or the output of the sine function? Are you given the angle or the ratio? Input or output? You're given the output. You're given the ratio, right? So that's always nice to keep that in mind. This is not an angle. Not an angle. It's the output for whatever the angle happens to be. The angle is the input, and we're not told what it is. And we're not even asked to find the input. We're asked to find the tangent of the same input. Okay. So the trick to a problem like this, whenever you're given a trig function equal to one of its ratios, is, I don't want to say whenever, but usually you're going to draw a helper triangle. Usually. So just draw any old right triangle. Doesn't really matter if you get the lengths correct. I mean, they might be off here, but it doesn't matter. So in other words, I know that the sine that's the so part of SOHCAHTOA, right? It's opposite over hypotenuse. I know that the hypotenuse should be 5. Good. I'm going to draw this triangle. I know that the hypotenuse should be 5, and which side, if I put theta here, it depends on where you put theta as to which side's the opposite, right? If I put theta up in the upper corner, the opposite side would be the horizontal side. In this case, the way I've drawn it, the opposite side has to be this guy, 3, right? Okay. So if now I happen to know the adjacent side is going to be 4 even without using the Pythagorean theorem. And if I had drawn it so that that side looks shorter, that side of length 4 looks shorter than the side of length 3, is it going to affect your actual numbers? No. So that's not a big deal. Just draw it so that it's a right triangle and you'll be okay. Now, how did I know that's going to be 4? It's a Pythagorean triple. You could check it. 4 squared plus 3 squared equals 5 squared if you're not sure. And if you're really not sure and you don't have those Pythagorean triples memorized, you could just label it x and go x squared plus what squared? 3 squared equals 5 squared. And if you solve this for x squared just like we did in the last problem, you end up 5 squared minus 3 squared from both sides, 16. Take the square root, you do end up with that 4. So I skipped some steps there because we just did that sort of thing in the last problem. But you can get it using the Pythagorean theorem or your knowledge of the 3, 4, 5 triangle, if you like. Oh, do you guys see why we call that a helper triangle? What's the tangent of theta? The TOA part of SOHCAHTOA leads you right to the answer. Opposite TOA. Tangent equals opposite over adjacent, right? So the tangent of theta is equal to opposite over adjacent. It's 3/4. And that's all they asked for, so we're done. Okay? Now some students do some weird things on this problem. They say the answer is the tangent of 3/4. It's not, but they get the input mixed up with the output. So try to avoid those mistakes, right? So the answer is just 3/4, really. The output of the tangent of theta. That's the answer. I circled the whole thing just to indicate what it is I found.